Over the next few weeks, I'm going to be putting together a number of small focused videos that show off some of the cool new features that are becoming as part of the Visual Studio and .NET Framework Orcas release that will ship later this year. For this first video, I'm going to provide kind of a brief introduction to how you can use LINQ to kind of dramatically ease data access. And if you're not familiar with LINQ, what LINQ does is it makes querying and the concept of querying data a first-class programming concept within .NET. And you can use LINQ to then go ahead and query relational databases with it. You can go ahead and query XML files, and you can go ahead and query, in fact, any object built in with .NET, which makes it kind of a really powerful concept and dramatically eases and increases the productivity with which we work with data. So for this particular sample, I'm just going to start off with doing something fairly basic, which is build just sort of a simple data reporting page that displays some data coming from a SQL database that I have on my box here. And right now I'm running a fairly recent build of Visual Studio Orcas that is actually running inside a VPC image on my laptop. And but it's going to go ahead and let us show off some of these cool features. So to begin with, I have a blank project other than a simple style sheet style sheet file that I included. And to begin with, I'm just going to go ahead and just build a page. We'll just call it myreportpage.aspx that we use to go ahead and display our data. And one of the things I'll do here is we'll just go ahead and say, call this page LINQ sample. One of the things you'll notice with Visual Studio Orcas is we have a kind of a significantly improved HTML designer that'll be included as part of it. It actually uses the same WYSIWYG design engine that shipped as part of the Expression Web Designer product late last year, and really provides a lot of really slick features. One of the most popular ones I think that people will like to take advantage of this thing is this thing we call Split View. What Split View does is it, for example, I can go ahead and type in Source View, and you can see it immediately allows me to see the changes inside Design View. If we want to go ahead here and say my LINQ sample, you'll notice it also automatically updates Source View as I'm typing. So easy way to go ahead and work back and forth between Design View and Source View in a very clean way. Now for this page here, let's just go ahead and actually add our CSS style sheet rule. Make the page look a little bit more attractive here. And because I'm going to be displaying some data, I'm going to go ahead and use the built-in ASP.NET Grid View control to go ahead and render it. Now you'll notice right now this grid view just has sort of a boring basic style associated with it. It's unstylized. Obviously I could use some of the auto formatting features inside the grid view and kind of embed my style information directly in the grid. Alternatively, I can go ahead and use one of the cool new designer features that VS Orcas provides, which is the CSS style manager. And so what this lets me do is actually in design time I can go ahead and see all the style sheet rules that can be applied to a particular element that I have selected in the designer. And so you can see there's this grid view rule that I define inside my style sheet. And then if I want to, I can just go ahead and say apply the style to any element I have selected, and you'll notice it's gone ahead and automatically added the appropriate CSS style sheet rule to that grid view control, and now I have a nice CSS stylized grid on my page. Now, having a grid on the page is useful. Obviously, what I want to go ahead and do next is retrieve some data and bind it against it. So to do that, we'll go into our code behind file. This looks just like it does in the Visual Studio 2005 release. Within this code behind file now, what I can go ahead and do obviously is write some code to query against my database, retrieve some data, and bind that data against my grid view. Now there's a couple different ways I could do it. I could use ADO.NET directly. Alternatively, I'm going to go ahead and, as I mentioned earlier, use this new technology we call LINQ, which lives inside the system.link namespace within .NET now. And specifically with this, I'm going to use another new feature that ships as part of LINQ, which is the LINQ to SQL object relational mapping support. And what this does is it's going to go ahead and let me create a data model that is an object-oriented class hierarchy that represents what my data within the SQL database looks like, and provides me a nice object-oriented way that I can interact with that data and then use LINQ to query against it. So to start off with, I'm just going to say add new item. create this link to SQL file, which will contain and define the data model for my application. So I'm just going to call this Northwind because we're going to be going against the infamous Northwind database. And you'll notice when I go ahead and run this or create this new file, it's going to give me a nice WYSIWYG design surface that shows me the object relational mappings inside this Northwind data model. And right now you'll notice there are no mappings. I can start off with defining classes and then map those into my data if I want to. So for example, I could drag and drop a class, define properties for it, and then set up the mapping rules to go against the database. Alternatively, I can just go ahead and drill into my Server Explorer here, and if I want to start off from my data, I can just go ahead and drag and drop the tables I care about or the stored procedures I care about, and this will go ahead and the designer will automatically create, in this case here, for example, a product class that has properties that map to the schema in the database. And likewise, I could go ahead and let's just add a categories class. You'll notice that the designers automatically inferred that there is a foreign key primary key relationship between the products and the categories table, and so it's automatically set up what we call an association between these two classes, which means that a category will have a collection of products, and each product will have a reference to the category that it belongs into. Hit save, and we're done. We now have a data model with relationships set up between the classes that we can then go ahead and write code and query against. So let's go into our code behind file now. Now, obviously, if I wanted to, I could go ahead and create a separate class that encapsulated all my data querying logic in kind of a nice business facade, and that's probably what you'd want to do in any kind of non-trivial app. For the purposes of this sort of simple sample, I'm just going to go ahead and write my querying directly in the page, just to kind of show off how to use LINQ. So to interact with my data, the first thing I'm going to go ahead and do is I'm going to go ahead and create what's called the Northwind data context, and that is a class that was created when I created that Northwind mapping object relational model. And I'm just going to call this DB, and we'll say new Northwind data context here. And through this class, I can then go ahead and very easily query for data. And I can use this new LINQ syntax to go ahead, LINQ support to go ahead and do it. So the way LINQ works is I can go ahead and very easily define a variable here. We're just going to call it query. And I can then go ahead and use this new LINQ syntax, which is a language syntax that's been added into C# and VB and can be used within any .NET language, to go ahead and express kind of how I want to get some data out of my data model. The syntax for doing this looks a little bit like regular SQL. We kind of deliberately did that so that it's a little bit easier to understand. So you can see here I'm going to say bring out a product inside the db.products table collection, and I'm just going to go ahead and say select out of that a product. Come back here and talk about the syntax a little bit more, but this is sort of the basics of what we need. Then I'm just going to go ahead here and take that grid view, and I'm just going to go ahead and set its data source equal to this query, and then I'm just going to go ahead and say call data bind on it, and then we'll just go ahead and run this. So let's go ahead and build our project as well as kind of launch our little built-in web server that ships in VS 2005. And what you'll see now when we go ahead and run this page is basically a grid that has a whole bunch of data populated from the products table within the Northwind database. So, what exactly happened here? Well, what happened here is when I went ahead and used this LINQ query syntax against my data model, LINQ to SQL was able to automatically take this query syntax and transform it into regular relational SQL expressions. And it just went against the database returned the content, and LINQ to SQL went ahead and constructed a set of classes, in this case product classes, that represent the returned data. And then I can just use standard ASP.NET data binding techniques to go ahead and display them. What's powerful about this query syntax is the kind of the expressiveness that you get with it, and the fact that it provides a nice, strongly typed, object-oriented way to query and interact with data. So, for example, here, if I wanted to add a where clause, I could certainly do that. I could say where p dot. You'll notice you get IntelliSense as when you're working with LINQ queries, so you can see you get strongly typed IntelliSense against your data model classes. So if I wanted to say where a category equals 2, I could do that. Hit refresh in my browser, and you'll see now I'm only getting back the product categories that are in category ID equals 2. So fairly standard filtering semantics. What's nice though is about LINQ, and specifically about LINQ to SQL, is that you'll remember when we constructed our data model, we identified 2 classes, both the product and the category classes, that we wanted to include inside our data model. If you remember, I said each product has a property called category, which basically maps basically maps it to the category foreign key inside our database. And what this means is now when I code against the product, I can always get access to its category object, and I can also use that category object as part of my LINQ query. So for example here, rather than say category ID, I could just change this to say category name. Notice again we get nice IntelliSense. And I could basically just say beverages. Oops. And now, again, you'll notice I get back the right data. So I can go ahead and use these kind of relationships to very easily express the data I want, and the LINQ to SQL object relational mapper will automatically construct the appropriate SQL joins for me in order to go ahead and retrieve the appropriate data. And so for example, I could even do something like starts with, and so rather than just get beverages, let's actually get back all of the categories that start with the letter C. And away we run, and now you can see we get even more data being returned, all from the categories that start with the letter C. Oftentimes when people see this, the first thing they ask is what's the magic going on under the covers, and sometimes people are very hesitant about kind of giving up their ability to control exactly what SQL is actually generated. So one cool thing about LINQ to SQL is that it makes it actually very easy for you to go ahead and see exactly what SQL it's actually executing under the covers. In fact, you'll notice here I'm just going to set a breakpoint, and we'll go ahead and run this page again. And this is obviously going to break inside the debugger. If you ever want to know kind of exactly what SQL is being executed for you as part of your object relational mapper, you can just go ahead and drill into it within the debugger. We'll have a nice debug visualizer before we ship, but you can see here you can just go ahead and right click on a query, and you can basically see exactly what SQL has been generated. And one of the things you'll notice is it's very clean SQL, doing kind of all the appropriate stuff for you when you do your queries against the database. So it's very easy to see what SQL syntax is being generated. The other cool thing about it is if you really want complete control, LINQ to SQL gives you the ability to kind of drill in, and you can actually optimize or custom tune the SQL yourself using either a stored procedure, or you can actually embed the actual raw SQL inside your object relational mapper if you need to. Again, if you want complete control of your SQL syntax, you have that ability. In general, though, for 99.9% of the cases, I think you'll probably see that the SQL that's generated by LINQ to SQL is as good or better than what you might have written from scratch. Now, in this particular sample, you'll notice that when I run the page, I'm actually retrieving all of the product data from the database to populate that product object. So I get the product ID column, the product name column, discontinued, quantity per unit. Now, in a lot of cases, though, when you're working with data, you don't want to retrieve all of the data from a particular row or from a particular table, especially in reporting scenarios. You often just want to go ahead and retrieve the individual columns that you care about. Now, the good news about LINQ to SQL is it makes it pretty easy to do that. I can just go ahead and adjust my select statement from retrieving the entire product to instead just specifying the 2 columns I care about right now, which is product name and product ID. Again, you'll notice you get full IntelliSense and compile time support for that. And now when we go ahead and refresh our page, you'll notice I'm just retrieving now those 2 particular items from the database. LINQ to SQL is automatically changing my select statement, so it's just those 2 columns of data that's returned, and then I can go ahead and populate it. Now, this feature is useful not just for restricting what columns you retrieve, but also providing the ability to kind of reach out into other entities related to an individual product and either do subqueries or basically do calculations or aggregate calculations which retrieve additional data that you might want to go ahead and populate on this object. What do I mean by that? Let's give a specific example. Let's say I want to know the total number of orders for a specific product as part of my report. So I want to know how many units were sold and maybe like the total revenue for each unit. Now, if we go back to our data model that we built earlier for the Northwind, you'll notice I just right now have a product and a category entity on the design surface. And there's no way directly from a product to know how many have been sold. Instead, if we go back to our database, that information is actually stored not on the product entity, but actually via the order details and the orders table. And so basically each order represents an order by a customer, and the order details table goes ahead and represents an individual line item as part of that order. And so each order has a collection of order details. Likewise, each order detail points to an individual product, and likewise then by adding this to the design surface, you'll notice that LINQ to SQL has automatically created an association so that each product now has a collection property of the individual order details associated with it. This is all by default inferred using the foreign key primary keys in the database. As I mentioned earlier, if you want to create custom associations using your own rules, you can easily use the design surface to modify them or add to them. Now what this means now is because I've set up those relationships, I can take advantage of them within my LINQ query. So for example, if I wanted to know the total units sold, now that I have that association set up, I can actually just say take advantage of p dot order details. If I wanted to know, for example, how many individual order details there were, I could actually just use the count property on top of that collection. But because I want to know the individual, the total number of units sold, I actually am going to use the sum statement here, and I'm just going to say, for each of the order details, let's actually go ahead and sum up the quantity in all those rows. And so again, this is going to go ahead and retrieve back an integer, which is the summation of all the quantities inside the order details associated with that product. We'll compile, hit refresh, and now you can see here are the total quantities for each of these products that was purchased. And let's go ahead and if we wanted to continue this, we could just go ahead and add a revenue. We can spell it right there. And so in this case here, we're also going to be summing up. The difference here is instead of just retrieving the quantity, let's also go ahead and multiply this by the unit price for that individual item. Hit refresh, and oops. As you can see here, one nice thing is we actually get syntax checking. As you notice, I forgot a comma there. That's when I built. The compiler gave me an error. That's one benefit of LINQ, is even though it gives you a lot of the expressiveness of a dynamic language, it's still in a strongly typed language like C# or VB will give you full syntax checking and obviously IntelliSense. So in this case here, I just basically took for each order item, multiplied its quantity times its unit price, and set up this column called revenue that's been retrieved. And again, if you're wondering kind of, gosh, under the covers, what is the object relational mapper doing if you don't trust it? Totally understandable. Cool thing is just set a breakpoint and hover over your query, your LINQ query inside the debugger, and we can just go ahead and pull this up, and you can see exactly what's being generated. And as you can see, it's just standard SQL. We got some joins here, and we're just basically doing some aggregate functions as part of it. And then executing. So optimized SQL, very efficient performance. You can do thousands of pages a second on a typical server using this, and away we go. So that's sort of an example of doing some dynamic computation on the fly. The last thing I just want to go ahead and show off with LINQ to SQL that I think is pretty cool, especially for web scenarios, is the ability to do what I call server-side paging support. So if you're familiar with a web scenario, typically if you have, say, a database with thousands of rows of data and you want to display them on a page, well, typically you're not going to be able to display thousands of rows on a page very efficiently. And so, oftentimes what you want to do is just show 10 at a time. Now, a challenge with a large database table is you ideally want to do that paging in the database layer. You don't want to retrieve 1,000 rows and then only, truncate and show 10 of them. Instead, you just want to retrieve the 10 rows you care about. SQL Server actually, in the 2005 release, has support for this using something called row number. And I wrote a blog post back in January 2005 if you're interested to learn more about how to use that. The challenge is, from a SQL syntax perspective, it's fairly difficult to use, and typically what people do is they create a stored procedure in order to enable it. With LINQ to SQL, there's a much more elegant way to do this. It basically supports a method called skip. And so we could just say, let's skip 20 rows into our sequence, and then I can use a method called take, and I can say, let's just return 10 rows back from the database. I'm basically appending these statements onto a query that we defined earlier. I could just as easily wrap this in a parentheses and add it directly in there. Because LINQ is only executed when you first go ahead and actually query the data, so it's part of my data bind operation, I could alternatively just stick them here and they'll go ahead and execute. And now when I go ahead and build my page and run this, you'll notice I'm only going to see 10 records returned, and it's basically about 20 rows into the database. Now, if I want to be able to see exactly what's being executed in the database as part of the sort of skip and take operation, again, the great thing is I can just go ahead and set a breakpoint. Go ahead and debug that application, and what you'll basically see is, just like before, obviously I can go ahead and get back or copy the SQL statement that's being executed. Hit view here, and you can see effectively we're automatically using SQL 2005's row number support. So again, we're only retrieving back 10 rows from the database. So even though this might be a table with thousands of rows in it, we're only going to go ahead and retrieve back the 10 that we're going to go ahead and display at the web server level. And so again, what this means is sort of dramatically improved performance, because I'm not pulling back thousands of rows. I'm just bringing back 10 at a time. And obviously I could change this from being a hard-coded number to being kind of a variable, and I could very easily, via a query string or a appended slash on the URL, easily go ahead and indicate which set of rows I want to go ahead and return in that overall sequence. So anyways, hopefully you've seen with this sort of simple sample some of the power and expressiveness that the new LINQ language features give you. The really powerful thing about it is you can use LINQ against a SQL database like we're doing here. I'll show in a future segment how you can use the exact same syntax against an XML file, and I'll show in another sequence exactly how you can go ahead and take this and execute LINQ state expressions against in-memory .NET objects. And so it's the same syntax across all of them. It's all strongly typed. You get full IntelliSense and compile time checking. And the other cool thing that I'll show a little bit later is how you can take these different data sources and actually do joins across them. So you could, for example, query in-memory data and also then do a join against it with a database and do another join against an XML file. And all these concepts from a language perspective build very nicely and are very composable within the language. And the end result for you, hopefully, will be dramatically improved productivity, great performance, and much better applications. So stay tuned to my blog. I'll post more segments in the near future. All the demos I showed here are with a recent build of Visual Studio Orcas, as I mentioned. This particular build and all the features in it will be available as part of the next CTP drop. That'll be coming out in only a few more weeks, so you can go ahead and download it and try it out yourself. Thanks a bunch for watching. Hope to see you soon.